Greetings, welcome to today's lesson on surface area of prisms and cylinders, focusing specifically today on cylinders. So let's start right out with, well, what is a cylinder? A cylinder is a 3D object with two parallel bases, and there's that capital B that we saw in the last lesson, because we're going to be talking about its area, and capital P tells me area. Two parallel bases that are circles. Now I'm sure you've seen this before, this shape before, so here we are, a cylinder. Okay, nice and easy. And if I can pop off the end here, you can see very clearly that this end is a circle, and there's one just like it the other side. So we're looking at the surface area of this object right here. Now, in our definition of a prism, we said that the two bases that are parallel can be anything. It could be triangular, they could be rectangular, they could be square, they could be trapezoids, they could be rhombuses, they could be anything. I was about to put those together and make a trombus. They could be anything, as long as they're the same. And then all the other sides are rectangles. Well, in a cylinder, our bases are circles. What's the outside of the cylinder shape? Surprisingly, or maybe not surprisingly, here's my cylinder, here's the outside. Because if I wrap it around, you can kind of see it wrapped around. When I unfold it, it's a rectangle. Just like every other prism. So two parallel bases that are circles and a rectangular piece. Let's just call it a piece. If we unfold it, it looks like this. A rectangle and then a circle on one end and a circle, and they would be touching. But that's what it looks like if we unfold it and laid it flat. That piece of paper and that end that I just popped off to show you. So it's nice to know what it is, but how do we find its surface area? Well, here's where it gets really, 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 really nice. How do you find the surface area of a cylinder? Surface area equals 2b plus pH. We saw that for every prism. I know that P stands for perimeter, but it also kind of reminds us that it's a prism. It's also the perimeter, it's prism, P. But what is it? What do we call the perimeter of a circle? Oh, you know what? We call the perimeter of a circle, we call that the circumference. Okay, so what's the surface area of a cylinder? 2b, no, it's the same, plus the circumference times the height, ch. So the only thing that changed was really nothing, just the word we use to describe it. If it's a prism and it's a straight line side, we call it the perimeter. If the base is a circle, then we call its perimeter circumference. So these really are exactly the same, except for the name. So where we would find the perimeter of a rectangle by adding up the sides, we have a formula that we need to remember for circumference. And we do need this formula. Circumference equals 2 times pi times the radius, or sometimes we see it as pi times the diameter. Those mean they mean exactly the same thing. And you'll see that when I do most of my calculations, I like to leave pi in the answer and not bother wasting time multiplying by 3.14 or 3.14159 or whatever, or hitting the button on my calculator, because in truth, I'm not gaining anything by doing that. If I told you the answer was 8 pi, that's exact. That is the exact. If I said the circumference was 8 pi, let's say inches, then I'm being exact in my measurement. If I take the time to multiply that by 3.14, now I'm being approximate because I've taken a number, pi, and I've cut part of the decimal off and then multiplied. So I've rounded it, and now I'm not exact any longer. And I never want to do that. I always want to be exact when I can be exact. So let's do one. Let's find the surface area of a cylinder. So first we're going to draw it. So there's my cylinder. Again, not perfect, but close enough. Now remember, in order to find its area, we've got to remember that one. So the area of a circle is pi times the radius squared. So I need the radius. Okay. Well, what if I'm given the diameter? What if I'm given the whole length all the way across and told that that was, let's make it easy on myself. We'll make that 10 meters. Well, what if I'm given that? Well, that's the diameter. So the diameter is 10 meters. Well, I need the radius. So the radius is the diameter divided by 2. So 10 meters divided by 2 is going to be 5 meters, and that's going to be my radius. And now I'm ready to plug that in for this. And I'm going to replace A of circle with the B. There's my capital B. Remember, that's what it stands for. The capital B says that what's the area? The two bases. And you notice it's lying sideways because, again, here's my cylinder. It doesn't stop being a cylinder if I lie it like this. It doesn't stop being a cylinder if I face it to you like that. Stand it up, turn it. It's still a cylinder no matter how I spin it. So we're looking at it like this. So pi times 5 meters squared is going to be 25 pi meters squared. And again, notice I'm leaving pi in my answer. If I absolutely had to do it for some reason, I would use as much of the decimal as I could, meaning I'd probably type it into a calculator and hit the button and let it go as far as it can. But until then, I'm going to leave it as 25 pi. If I were taking a test or something, I might even just be able to estimate and say, you know what, it's probably around 3, call it that, and then look for the one that's closest to that. Maybe, I know it's a little more than that, so I'd say let's the one a little more than, say, 75. Otherwise, I always leave pi in my answer. Well, surface area says I need the B. I also need the C. Well, we saw that a minute ago, and I'll write it again here, is pi times the diameter. Well, I already know the diameter is 10. So 10 pi meters. And then what's the height of the cylinder? Well, I didn't give us a height yet, now did I? Because that's going to be this distance right here, from one base to the other. Okay, from one circle to the other circle. So this distance right here, and that's the height of the prism. Or in this case, height of the cylinder. So let's just make it easy on ourselves. We'll make it 12 meters. Notice I don't have to calculate anything. It's just I have to look at the graph. I have to look at the graph, look at the drawing, look at the picture, and see it's 12 meters. Once I have that, I have all of my numbers, and I can simply plug them in and calculate. Two times 25 would be 50. And notice I'm still leaving pi every step of the way. 10 times 12 is 120. And there's that pi. So pi, meters times meters gets me meters squared. So now both of these are, notice they're both meters squared because I'm finding area, surface area. Now I can add them because I have 50 pi and 120 pi. Think of them like pi as like an object, like pies, right? I have 50 of them here and 120 of them there. So I have 170 pi meters squared. Now, if I had to multiply by 3.14, this is where I would do it. Because if I do it up here, then I've got a 4-digit number at least with multiple decimals, and I've got to work my way through, and it's a real hassle. If I wait until the very, very end, it's far less of a hassle. It's not that it's not a hassle anymore, it's just way easier if I wait until I've gotten to the very end of the problem before I decide to finally multiply by pi. And even then, I don't want to do it. If it came to me and I was on a multiple choice test, I would say what's 170 times 3 is about 510. Where's the one that's a little more than 510, something like 520 or 523 or 530? That's the one I'm looking for. And there won't be one near it. I promise you that. Because they expect you to make very different mistakes that are much more, that play out much bigger than rounding the 3.14 to 3. Okay? So the only thing that changed was our description here. And in fact, sometimes I like to do that and just say perimeter equals circumference equals, this is how we figured it out. Okay? So I want to do one more. And when I do this, I'm going to give you a step-by-step guide. And this is great. I think this is super helpful, and it'll be very helpful when we get into volume, which will be the next set of lessons of cylinders and prisms, and even then cones and pyramids. All of that comes back to this. So first I'm going to draw a cylinder, and I'm going to draw it a little weird. So here's I'm just going to give us the radius, make it 4 inches. And then I'm going to draw like this. This is what I referred to in the last video as an oblique. This would be an oblique cylinder. The big difference is that we don't measure the height at this diagonal. We would measure the height here. Let's make it 8 inches. If they give you this number, we're going to ignore it. Something referred to as slant height, and there are very few things you want where slant height matters. So in fact, I'm just going to erase it right off the bat. We want to know how far it is at a right angle from base to base, even if the bases are far apart. We just want to know. It's kind of like, I want to know how high your head is off the ground if you're leaning way back or something like that. Okay? Just to the ground. Always to the ground. Okay? You won't see very many oblique prisms, so you don't need to remember much of this. Okay? But here we go. Let's do the step by step. And the nice thing about cylinders is we only need 2 numbers. The radius and the height of the prism, and we're done. So let's start with step 1. Name the shape. Now, why do I want to do that? Well, in the cylinder's case, it doesn't really matter. But when you get into the different types of prisms, it matters quite a bit, because at that point you're really naming what the base is. Okay? If you call it a triangular prism, you're telling me it's a triangle. If you're naming it a rectangular prism, you're telling me the base is a rectangle, and so on. Okay? So, cylinder. Now, why is that important? Well, because, actually, here, I'm gonna write the steps. Yeah, I'm gonna write the steps there, and I'll write the answers over here. So we're gonna start with name the shape, and then so we call this a cylinder. Step 2, redraw the base with the measurements. Okay, we want it because most of what we need is based on the base. We need the area of the base for the B. We need the circumference or perimeter of the base for the P or the C, depending on. So it's almost all revolving around the base. So here I get to draw a nice circle with a nice 4 inches measurement. Then we find the area of the base. Now there's all those formulas that I gave you a while ago, how to find the area of a rectangle, a triangle, and in this case, a circle we know is pi r squared, which is pi times 4 inches squared, which is 16 pi inches squared. Then we want to find the perimeter of the base. Now, what do we call, when we're dealing with a circle, we call the perimeter circumference, and that is 2 times pi times the radius, or simply 8 pi inches. So perimeter equals circumference when we're talking about circles, so we're finding the perimeter of the base, which is also called the circumference. Step 5, this is easy. Identify the height of the prism or cylinder, depending on which one we're dealing with. And that's always going to be remember, from base to base at a right angle. Usually it's the number you haven't used yet. It's almost always the number you haven't used yet. Again, being careful, if they give you slant height, then they may give you too much information, then you got to figure out which one is which. You always want to see this little T here. Sometimes you'll even see a little box there to remind you you want a right angle when you're looking for the height of the prism or the cylinder. But in this case, it's just a straight number, 8 inches. And then solve. Find. And the reason I put solve here at the end is when we get to volume, which will be our next set of lessons, we'll use a different formula, but the steps will be nearly identical. In fact, the only thing that's going to change between these steps for finding surface area and these steps for finding volume is we're going to take out step 4. We're going to take out a step. We're going to make it easier. When we deal with cones and pyramids, same thing. Same set of steps, take out step 4. So that's why these steps are so valuable. If you can follow these step-by-step instructions, you can find the surface area of every prism, every cylinder. You can find the volume of every prism, cylinder, cone, and pyramid. Because you can follow the steps. And you may get to the point where you're like, I don't have to waste time naming the shape. I know that's a cylinder, I can see it. I don't even need to pull the base off. I'm so used to doing circles that I can just, boom, I see the 4 inches here. I know that's my radius. I'm ready to go. The more you do it, the less you'll need to do it. It's one of my favorite statements about a lot of the math that you find yourself doing is you do it and then you go, okay, I've done it a bunch. I can kind of do these 2 steps together because I know this, I don't need to redo it. And this would be this formula, 2b plus, because we're using circumference, CH. So, and yeah, we still see me. So 2 times 16 pi inches squared plus 8 pi inches times 8 inches. And we're going to get 32 pi plus 64 pi. I'm just leaving the units off for 1 second here and get 96 pi inches squared. And if I absolutely, and I don't know if you can quite see that, probably not. Let's put it up here. So we got 32 pi plus 64 pi equals 96 pi inches squared. And now, if it's funny, if I actually had to multiply by pi, especially for multiple choice, I'd go, well, I'd round that up to 100 and then multiply by 3, and I'd say I'm looking for something close to 300. And I assure you, I would only find one answer, even close. And I know that's right. I would know that it is correct because I have done all this other math. But again, if we can follow these steps, we can find the surface area of every prism, every cylinder. We can find the volume of every prism and every cylinder, and cone and pyramid. All we got to do is take out step 4 for those last few. And there's a slightly different formula. For the volume, we'll see base and height. For cones and pyramids, we'll be dividing by 3. That's about it. Real small little tweaks, but this is it right here, step by step. Do that and you're going to get the right answer every time. And for me, that is always your goal. If you have something that lets you get the right answer every time, you should use it. If it's a little slow, don't worry about it. Okay? Yeah, you'll probably take the occasional test where time may not be your friend. But if you've got a method that lets you get the right answer every time, I don't know why you wouldn't use it. Okay? And that is the surface area of cylinders. And a little bit more about prisms as well. Okay? I look forward to seeing you in class.